Hi and welcome back to Maths class. Today we're going to have a short lesson to think about how do you choose which rule to use. So far we've learned 3 different rules for differentiating: the chain rule, the product rule and the quotient rule. And whilst you're just practicing one, it's pretty obvious which one you're supposed to choose because you're in the chapter called chain rule or quotient rule. But of course in the exam you're not going to know which one you're supposed to use. So these are the things that we need to look at when we're deciding what we want to choose. First of all, we know that the chain rule we use when it's a composite function. So if it's a composite function, that means that I can identify an inside function. F of x equals g of h of x. And we'll look at an example in a minute. Product function, product means multiplication. So I can identify 2 functions that are multiplied together. F of x equals g of x times h of x. And finally, the quotient rule means I've got a fraction of 2 functions. So I can identify a different function on the numerator and denominator. F of x equals g of x over h of x, with the extra point that it can't be simplified. So if I had a polynomial all over x, I would be able to simplify that, and therefore I wouldn't need to use a quotient rule. Although if I didn't notice and I did use the quotient rule, I'd get the right answer, but I'd just have to do a lot of extra work that's unnecessary. So let's look at a few examples just to identify what's going on here. So for my chain rule, here I've got an outside function sine and an inside function x cubed plus 2x. So if I think about that and I ask myself, what do I do to x? Well, first I have to cube it and add it to 2x, and then I take the outcome of that and I sine the outcome. Okay, so I have to do 2 things. First I apply this cubic function and then I apply the sine function. In my product rule, I do those same 2 things, but I do them separately for the original x value. I put my original value of x into this, I put my original value of x into this, and then I multiply the outcome. In my quotient rule, it's very similar to the product rule, but I'm dividing instead of multiplying. Quotient rule is pretty easy to identify because it looks like a fraction. So what I'm going to do is I'm going to take you through some examples and we're going to talk about, would I use the chain, the product or the quotient rule to do this problem? So here I've got f of x equals root x times cos 3x. One of the things I'm going to do is I'm going to write down u equals root x and v equals cos of 3x, because I can see that I've got 2 functions here, root x and cos of 3x. Now, how are u and v connected? If this is u and cos 3x is v, they are multiplied together. So for this one, I'm going to use the product rule. All right, here's another example. Log base e of x squared plus 5x. So if I take my x value, first I'm going to have to apply this quadratic function to it. Then when I've done that, I take the outcome and I apply log base e. If I write down u equals x squared plus 5x, I don't want to write down v equals log base e of x because I don't have log base e of x. I've got log base e of some other function. So I can write this as log base e of u. This is a chain rule because I've got a composite function. Now in this one, I've got f of x equals sine x times e to the power of 3x. Now my big clue is here in this times, but I'm going to also write down my 2 functions, u equals sine x and v equals e to the power of 3x. So now I've identified 2 functions which are multiplied together. This is u times v. Therefore, it's going to be a product rule. In this one, f of x equals tan x over the square root of x. So I've got, if I let u equal tan x and v equal the square root of x, then what I have here is u over v. This one, I'm going to use the quotient rule. And the big clue is the fraction here. Okay, now in this example, it could be possible to rewrite 1 over root x as x to the power of a negative 1/2 and use the product rule. And if you've identified that and you want to go ahead and do that, that's fine, but it's perfectly okay here to just go ahead and use the quotient rule because it's written as a fraction. Okay, f of x equals e to the power of 4x cubed plus 3x squared. So hopefully what you can see here, I'm not multiplying two functions together. I'm not dividing two functions together. In fact, if I identify u equals 4x cubed plus 3x squared, then I can see what I've got here is e to the power of u. This is a composite function, so I'm going to use the chain rule. In my last example, once again, you've spotted it, it's a fraction. It's going to be the quotient rule. And I can see that because it's a fraction, but just to double check, I'm going to identify u as my numerator, cos 2x plus 5, and v as my denominator, x cubed plus 2x minus 4. And so I can rewrite f of x as u over v. The next step, of course, is to make sure that you then go ahead and find the derivative of every u and v that you've identified, and then that you correctly apply it to the rule. But that's a lesson for another day.